All right, now we're going to go to another method of factoring, trinomials. So in the past, so far, we've pulled out a greatest common factor, and we could only do that because we couldn't do the difference of two squares because that looks a certain way. A difference of two squares is when you have two perfect squares. So this is a perfect square, that's a perfect square. Notice that there are only two terms in here, so it's not by default a trinomial. Sometimes you'll have to factor things with three terms in it, trinomials. And we're going to focus on, in parentheses, I'm going to say, talking about quadratic functions. And we talked about quadratic functions before. That's when you have an exponent of 2, right? The highest or the leading or the highest degree is 2. In general, there is a standard form for all quadratics. It is ax squared plus bx plus c. Notice that the highest degree is 2, which makes it a quadratic. So I'm going to ask you to factor them, and it might be easier for me just to kind of go through and do it by way of example. There are many methods of doing this. I'm going to stick with one method. It's called the Berry method. I didn't create it, but I found out about it a few years ago, and it works all the time. I'm going to start off with a simple case, but then kind of go through. Actually, you know what? I'm going to do them all exactly the same. So let's just do that. Let's go with, what if I said 3x squared plus 5x plus 2. That's a trinomial. All right. I want us to be able to factor this thing. That means I want it to look like two things multiplied together. That's what we're talking about when we factor. Now, when you factor this, what you really need to do is to find factors of, so with star, I'm going to say, find factors of a times c. Remember, a is the thing in front of the x squared, so 3. And then c is the coefficient or the constant by itself, c. Factors of a times c that sum to b. All right, so this is b. This is a, this is c. So that's what we're trying to find. Now, how is that going to look? Well, our goal is to factor. All right. Now, what the Berry method does is it kind of eliminates some of the back and forth of some of the other methods. What you want to do in the Berry method is whatever this is right here, write it here and write it here. So just write the 3x, write the 3x. Whatever it is, not the square, just whatever that is, write it in both places. All right. Now, with that said, in order to fill in the rest, I need to do this over here. I need to find factors of a times c. So a times c, in this case, is 3 times 2, or 6. I need to find factors of 6 that add up to b, or 5. Now, if I did 1 times 6, when I add those, I get 7. So no, that's not going to work. What about if for 6, I did 2 times 3? Well, when I add those, 2 plus 3 gives me 5, which is my b. So what I would do in the beginning is I would write out a, b, and c. A is 3, b is 5, c is 2. And I would use those to find this. Now, with that said, I found my pieces. My two factors are 2 and 3, a positive 2 and a positive 3. When I add them together, I get 5. So whatever is here, I write a positive 2 and a positive 3, because those are my two factors. All right. Now, the thing is, if I multiplied this out to check it, 3x times 3x would give me 9x squared. There's an extra 3 in there. But if I look at it, can I factor out a 3? So if I divide out a 3, then I would actually get, when I divide that out, I would just get x. When I divide 3 divided by 3, I get 1. This one doesn't have anything to pull out, so I'll just do 3x plus 2. Because I've done that, according to the Berry method, these are the two factors of that expression. If I multiply that out, I would get this expression. All right. So again, it's really just finding the factors of a times c that add up to b. You got to remember a, b, c of the standard form of all quadratics. We'll put that in a big box, and then we'll do some examples in the next video.